Assalamualaikum warahmatullahi wabarakatuh. For this video, for our assignment, we're going to explain about a principle, second the operation, third the application, and lastly we're going to show the result of our project.
Our project need to be implemented as below. First, this fire alarm system is incorporate the heat and flame detector that is connected to the flame sensor and microchip temperature sensor. Second, the microcontroller is used as a heart of the fire alarm system that control the entire operation involved. The third one, the fire alarm system is capable to locate and identify place that is in fire, whereby it is monitored by using the monitoring system. The last one is capable to display the output from each sensor in the monitoring system. Okay, now how it works? When supply is on, it will produce a magnetic field. Okay, now the process of magnetic field. Magnetic field is a vector field in the neighborhood of a magnet, electric current, or changing electric field in which magnetic force are observable. A magnetic field is produced by moving electric charge and intrinsic magnetic moment of elementary particle associated with a fundamental quantum property known as a spin. Magnetic field and electric field are both interrelated and are components of the electromagnetic force, one of the four fundamental forces of nature. Okay, our assignment, we follow the law that conclude in our syllabus. Okay, first we follow the Faraday law. Okay, Faraday law of electromagnetic induction consists of two laws. First, the law that describes the induction of EMF in a conductor, and the second law quantify the EMF produced in the conductor. Okay, first, wherever a conductor is placed in a verifying magnetic field, an electromotive force is induced. If the conductor circuit is closed, a current is induced, which called is induced current. Okay, the moment here are a few ways to change the magnetic field intensity in the closed loop. First, by rotating the coil relative to the magnet. Second, by moving the coil into or out the magnetic field. Third, by changing the area of a coil placed in a magnetic field. And the last one, by moving a magnet toward or away from the coil. Okay, second, the induced EMF in coil is equal to the rate of changing of flux linkage. The flux linkage is the product of the numbers of turns in the coil and the flux associated with the coil. Okay, here I attach with the formula Faraday law that you can see as below. Okay, now the second law is the Lenz law. The German physicist Heinrich Friedrich Lenz deduced a rule known as Lenz law that describes the polarity of the induced EMF. Lenz law states that the polarity of induced EMF is such that in turn to produce a current which oppose the change in magnetic flux that produce it. The negative sign in the formula represent this effect. Thus, the negative sign indicate that the direction of the induced EMF and the changing in the direction of magnetic field have opposite signs. Okay, for the third law is the Fleming right hand rule. Okay, for Fleming right hand rule, it shows that the direction of the motion of force, the magnetic field, and the current induced. Okay, we use right hand rule because they show the thumb finger for the motion of force, and fourth finger show the magnetic field, and the second finger show the induced current.
Next, I'm going to explain the operation of our project. First, the schematic circuit consists of electronic and electrical components such as board controller, flame sensor, temperature sensor, buzzer, and DC motor. Step 1. To turn on the system, the 6 volt of battery is needed to supply for the circuit. When the circuit is turning on, the board controller waits a signal from a sensor. Next, when the fire starts, a sensor will send a signal to the board controller, and at the same time, a board controller will trigger a buzzer and spin the DC motor to alert and give a notification to a system and security that a fire is happening.
Okay, now for the application component that require. Okay, first battery. Battery is electric field from inside a battery as it enter state of charge pointing to the terminal. And electromagnet is a type of magnetic field that is produced by electric field. Magnetic field are generated by the act of putting magnet in charge. Okay, second, buzzer. Buzzer is used to convert the signal from audio to the sound. Buzzer also produce the magnetic field, and it also change the energy from electric energy to the mechanical energy. Okay, now the third one is the PLC board. PLC board is our controlling the overall operation of the board, including the input and output of data and signal. It is connect to other components on the board, such as memory, power, and logic chip. Okay, the fourth one is a flame sensor. Flame sensor is to detect and respond to the presence of a flame or fire, allowing flame detection. Respond to a detected flame depends on the installation, but can include sounding an alarm, deactivating a fuel line such as a propane or a natural gas line, and activating a fire suppression system.
Component that required for this project: temperature sensor microchip, programmable solid-state temperature sensor that designed to replace a mechanical switch in sensory and control the application. Next, DC motor. DC motor is an electrical motor that convert direct current electrical energy into mechanical energy, and the force produced by introduced magnetic field due to flowing current in the coil. Next, DC motor fan blade. Blade will spin when the signal from the system monitoring that detect a fire through the sensor. That's all the explanation for our project. Thank you.